Okay, everybody. This isn't going to be pretty, but we're going to get through it. So I want to talk about what's called partitioning line segments. It's not terribly difficult, but I need you to pay attention, follow along, and work with me. Please don't work ahead. Please stay with me to make sure we all get the information. Okay, so here's what we have. If we have 3 points on a line segment, so we've got -3, -1 for point A, point B is -2, 1, and point C is 0, 5. Okay, it says find the following ratios, and let's connect those. So they want to know AB to BC. I don't want to actually find those links. What I want to do is think in terms of pieces, like we did yesterday when we dilated stuff. Think in terms of like little slope or little Pythagorean triangles to get from point to point. So to get from A to B, I go up 2 over 1. So if we call that 1 unit, let's consider how we get from B to C, up 2 over 1, up 2 over 1. Okay, so AB is 1 chunk of that, and BC is 2 chunks of that. So the ratio is 1/2. If we look at AB, which is 1 chunk, to AC, this is 1 chunk to 3 chunks. And if we consider BC, which is 2 chunks, to the entire thing AC, that's 3 chunks, it's 2/3. Okay? We are not actually going to find lengths, but you could, and you would find that this side, AB, is a square root of 5. BC is 2 square roots of 5, because it's twice as big as it. AB to BC is a 1/2 ratio. And if I find AC, it is 3 square roots of 5. So if you looked at BC, 2 square roots of 5, over AC, 3 square roots of 5, you get a 2 to 3 ratio. But we're not going to do that. We're just going to talk about these little slope chunks, if you will. Okay, so think of it in pieces. I want to talk about another way to write this. This could be written as AB colon BC, in which case it would be a 1 to 2 ratio written like that. Okay? All right, let's look at the next one. If DE has endpoints of -2, 3, okay, so that's D, and E is 6, -1, find the point Q on it such that DQ to QE is 1 to 3. Okay, here's what I want you to do for these. I want you to think of this. If it's in a 1 to 3 ratio, that's 4 pieces, or 4 chunks. Okay? Like AB to BC, it's a 1 to 2 ratio. It's 1 chunk to 2 chunks. It's a total of 3 chunks, or pieces. This one's 4 pieces. So I need to find point Q somewhere on here that's going to divide it into 1 to 3. Okay, so I need to divide it into fourths. All right? So consider the slope of the entire line, or the entire segment. So it's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. It's 4 over 8. Remember when we found midpoint, we did half of this, half of the y change, half of the x change? Now we're going to divide it into fourths. So if I divide 4 by 4, I get 1. So I'm going to go down 1. Let's use a different color here. I'm going to go down 1. And if this is 8 across, I'm going to go 2 over. So down 1, 2 over. Boom. Oh, that pen's not working. Down 1, 2 over. Down 1, 2 over. Down 1, 2 over, down 1, 2 over, okay? That divides it into 1, 2, 3, 4 equal pieces. And if I want DQ to QE to be in a 1 to 3 ratio, Q would have to go here. So I have 1 piece to 3 pieces, a 1 to 3 ratio. So Q is 2, 0. And that puts DQ to QE in a 1 to 3 ratio, okay? Let's try the other side. The other side is fractional. They want point R on here such that DR to RE is 1 to 7 ratio. That's 8 pieces. Okay. So if I'm going to divide these into 8 pieces, it's really easy to divide this side into 8 pieces. That means each one is over 1. But then if this is 4, each one is going to be up 1/2. So I'm going to do the one that's easy. I'm going to go over 1, up 1/2, over 1, up 1/2, over 1, up 1/2. sorry, that's halfway. Over 1, up a half, over 1, up a half, over 1, up a half, over 1, up a half. There's 8 pieces, okay? Now I need to put R on here such that it's in a 1:7 ratio. Okay, so I'm starting at D, and I want to go 1 over and put R right here. So that's 1 piece, and now RE is 7 pieces, a 1:7 ratio. So I have to think about where this point is. It's at -1, and it's halfway between 3 and 2. So -1 and 2.5. Okay? And I'm just doing it graphically. I'm not doing a bunch of algebra to figure this out. I used to teach this algebraically. It's easier just to look at the picture. All right, let's try a few more. FG has endpoints of -2, -3. So there's F. G is at 1,6, G. Find the point Q such that FQ to QG is 1 to 2. Okay, that's dividing it into 3 pieces. So consider the slope of the entire thing, divide it into thirds. 1, 2, 3. So this is going to be 1 across. Oh, I'm sorry, you can't see the picture. There you go. 1, 2, 3, that's going to be 3 across. And this is 9, so that'll be up 3. Okay, so do that. Go up 3 over 1. Up 3 over 1. Up 3 over 1. Now if I want Q to make it such that when you start at F and go towards G, it's in a 1 to 2 ratio. That would put Q right here, so that it's in a 1 to 2 ratio. Okay, let's do one that divides it into 6 pieces. This is not going to turn out nice and pretty. Okay. This is going to be a half for each one, and this is 9, and I'm dividing 9 into 6 pieces. It's going to be 3 halves for each one. Okay, my suggestion to you is to do the easy one, okay? This down here, each one of these is getting broken into a half. So if I start here, if I go up or over 1/2, I go up 3 halves. It needs to be on the line, okay? So if I go over a half, I land here. If I go over a half, it'd just be right here on the line. Over a half, up, over a half, up on the line, over a half, up. Okay, so that divided it into 1, 2, 3, 4, 5, 6 even pieces. I didn't really plot the 3/4 or count the 3/4. I just relied on the fact that I know these are divided into halves and it needs to fall on the line somewhere. So now I want to put R on there such that when I start at F and I go towards G, I'm in a 1 to 5 ratio. That would put it right here. This is 1 piece, and here's 5 pieces on the RG side. Let's find that coordinate. We're just going to think through it. We're not going to do any math. This is -1.5. Remember, I was going half this direction, so it's -1.5. And then up here, okay, so look at this. I'm at 0 here, I'm at 3 here, so halfway in between that is 3 halves, -3 halves, okay? All right, that's also -1.5. You could write it both ways, I don't care. Okay. All right, they get uglier. Let's try this last one. I'm videotaping a lesson. I can't talk. Okay, so let's do this, guys. We're going to look at points A and B on this lesson, or on this problem. So here is A at -4, 6, point A. And here's B at 4, -7. Sorry about that, students walked in. Okay. Find point C on the line that partitions it in a 3 to 2 ratio. Well, that's 5 pieces. Okay, so let's figure this out. All right. So this is ugly. This piece is 13 long, so 13 divided by 5. And this is 1, 2, 3, 4, 5, 6, 7, 8. 8 wide divided by 5. Okay, so that's really hideous. Okay. This one is kind of a little bit easier to do algebraically. I'm going to start here at A, okay, and when A is at -4, 6. And what I want to think about doing is I'm dividing this thing into 5 even pieces. So there's you know, there's some sections on here, 4 sections on here that would give me 5 even pieces. Sometimes when it's this ugly and this uncountable, it's easier just to do the math, okay? So I need to go 3 pieces down and 3 pieces over, okay? So I need 3 of these to go up and down, and I need 3 of these to go over, okay? So if you just do that math, this is 13 times 3 is 36 fifths. Okay, that's your vertical change. And this is 24 fifths. That's your horizontal change. Okay? So I need to, if I'm at -4 on my x value, I need to add to that 24 fifths. Okay, and that's going to leave me 4 fifths, if I did that on my calculator. This 13 fifths times 3, that's 36 fifths. I need to go down. I'm going to subtract that, because I need to go down this way, from 6 up here, down 36 fifths. And when I do that on my calculator, I get -8 fifths. Okay, and then I can look at where that point is. So here's 4 fifths, it's almost 1. Here's -8 fifths, that's almost 2. It's right here-ish. So that's where point C would be. So look what we did. We couldn't count this one. We couldn't count it. But what we could figure out was how big each piece is. This is my vertical change each time. This is my horizontal change each time. 13 fifths and 8 fifths. I needed to go 3 over. 1, 2, 3. I wasn't able to count it, but I could figure out how big it is and then just do the math, okay? So my x value was -4. I need to go 24 fifths this direction, so I added 24 fifths. I need to go, starting here at +6, I need to come down a total of 36 fifths, so I just subtracted it, and I got 8 fifths, and that gives me my actual coordinate. So you can do it algebraically, a lot harder. Okay? Let's flip the page over. Okay, this is just asking you to do some extra problems. I only wanted to point out one thing on here. These are called directed line segments, by the way, because you have to think about, I'm going from A to B, and you can tell that based on the way it's written. Okay, so I'm going from A to B, and they want point P such the ratio is 2/3. So you want 2 on the A side and 3 on the B side. So you have to look at these and see which one you think gets you into 2/3. This one here, this side is bigger, so that can't be it. This one, it looks like it's 1 to 2. That can't be right. This one here looks reasonable. That could be 2 to 3. That one looks reasonable. This one again, this is bigger than this one, so that can't be it. Okay. Here's one where you're just dealing with simple linear ones, okay? So here's AB, where you go from 0, 0 to 12, 0. So basically, it's a 12-unit line, okay? So now you're thinking without a picture or anything, but it's a horizontal line, so it's not that hard. Determine the point P that partitions it into a 1 to 2 ratio. So this is 3 pieces, and this is 12 long. So each piece is going to be 4 wide. Okay? So then you can figure out, hey, if you want it in a 1 to 2 ratio, where this point would be. It'd be at 4, 0. Okay? I'll leave you to do number 7 yourself, same idea. Okay? The rest of this is homework, so you're going to do some partitioning. It's a lot, you know, it's very straightforward. These are just true, false questions here. I'm trying to remember what else is on here. Okay, these two graphs here, you can use, let's see, I think you can put 12 on here, is what I did. And I put 13 and 14 on here, and nothing ran into each other. It seemed like it all fit okay. Okay? So the back is homework. All right, sorry it was so quick, guys. I did my best to get this done before I ran out the door. Thank you so much. Bye.